Okay, continuing with chapter 6.1 of example 4. What we've had in the first three examples was functions of x. Y equals something about x. Now we got x equals something about y. And our calculator does not graph those in that fashion. It has to be y equals to graph. So what I want to do first is get both of these to say y equals. So if I move the y squared to the left and the x to the right, I'm going to get y squared is equal to 9 minus x, which gives me y is equal to plus or minus the square root of 9 minus x. It's very important the plus or minus shows up to get the entire graph. If you just put the square root without the plus or minus, you only get the top half, not both the top and bottom. So the square root of 9 minus x positive is going to kind of look like that, and negative square root of 9 minus x is going to look like that, and then they meet somewhere. So it's going to be a sideways parabola is what it's going to end up looking like. We're going to graph these on our calculator in a moment. Do the same thing for this one. Y squared is already positive, so I slide the 9 over there. I'm going to get y squared equals x plus 9. Or 9 plus x, take your pick. So y is going to equal plus or minus the square root of x plus 9. You want to get them both to say y equals so your calculator can graph them. But this is going to be y1 and y2. And this one's going to be y3 and y4. Just because we have to make two graphs to graph it doesn't mean that they're not the same graph. So the top part and the bottom part together make the entire graph of x equals y squared minus 9. Top and bottom half together make this x equals 9 minus y squared. So if I go to my calculator, enter these, and you can see there's colors over here. You have the ability to make the same graphs the same color. So I've got blue and purple, so we'll go with those colors. So I got positive the square root of 9 minus x. I've got negative the square root of 9 minus x. And with negatives, again, be careful that you use the negative key down here. This is subtraction, that's negative. And then I've got positive the square root of x plus 9. And negative the square root of x plus 9. All right, and all you have to do to change colors on the graphs, if you cursor over to the colors there, if I hit enter, press to the right or left, it changes colors. So it starts at black. If I press to the right, it goes to the next color down. If I go left, it goes the next color up. So they're kind of in that order. So I want them both to be magenta. Cursor down to OK. I'm going to change the red to blue, so hit enter on that one. And I'm hitting the left because I want to go to one above it. Hit OK. If you had a calculator, you didn't have colors on it, maybe thin line, thick line, just to kind of have things of the same type. If we don't have a real idea of where these graphs are going to be, if we just do a zoom 6 to start off with. So the blue graph is x equals 9 minus y squared. The purple graph is going to be x equals y squared minus 9. So again, we get that sideways parabola. We get another sideways parabola. All right, now if we think back to how we did this in the first three examples, we were looking for a top and a bottom, right? This is on top, this is on bottom of the same graph. And that's on top, that's on bottom, that's the same graph. That's an issue. We can't do it that way because, I mean, I suppose I could. It'd be the top half minus the bottom half. But then you're taking the integrals of square roots, and it's kind of ugly. So we have the ability to make it a dy integral. We can do the furthest right minus the furthest left, and then we're going to look for a y interval from smallest to biggest. All right. So the way it looks like is this. Obviously, this is furthest right, and this is furthest left. What I need to know is the points of intersection. Where the region starts and where it ends. So it starts here, ends there. It looks like -3 and +3. Okay. But if we wanted to verify that, if I just did a calc intersect. Now we have 4 graphs we're playing around with here. So if you take a look, the top point of intersection up here is, if I just cursor over a little bit, the positive square root of 9 minus x is this part here. It stops right there. The bottom part's the negative square root, so we're looking for the intersection of these two. So if I hit enter there, notice it jumps to y2. I'm going to push up or down to get to y3. y3 is the other one I want. So these are the two that are intersecting up there. And then as far as the guess is concerned, it looks like 0 to me, so I'm going to type 0. Okay. The intersection point is 0, 3. I'm still picking an x value for my guess. All right. But the number I need is the y value. So the top is y equals 3. And if we look at the bottom point of intersection, again, second Calc 5, this time I want to pick the bottom curves. So if I press down, that jumps me to y2, which is the bottom part of the blue curve. If I press down, it jumps me down to y4, which is the bottom part of the purple curve. You can see those are the two that are intersecting. Again, I'm going to guess 0 and 0, -3. All right. So the main idea here is, what made me decide to do that was the fact that the same function made both the top and the bottom of this curve. So I had to subtract the top part minus the bottom part. That gets difficult. So doing right minus left is easier in that scenario when that happens. So once I've made that decision to do it this way, the area is going to be the integral from the smallest to the biggest of the rightmost minus the leftmost. So 9 minus y squared minus y squared minus 9 dy. It's the exact same formula, same way of creating it, except instead of top minus bottom on the left to right interval, it's going to be right minus left on the bottom to top interval. And then simplify like we did before. I've got 9, it'll be plus 9 makes a total of 18. Minus y squared makes minus 2y squared. And then we simply have to evaluate the integral. So the antiderivative of 18 is 18y. The antiderivative of negative 2y squared is negative 2y cubed over 3. It's a definite integral, so I can just go from negative 3 to 3. Go plus c is necessary. We substitute 3 in first, positive 3, so 18 times 3 is 54. 3 to the third is 27 times 2 over 3. If I put negative 3 in, minus times. Put negative 3 in, negative 54, and it'll be minus 2 times negative 27 over 3. So 27 and 3 reduced down to a 9, so we get 54 minus 18 minus negative 54, and this 27 cancels that to a 9. Minus minus makes plus, so plus 18. So I get 36 minus negative 36, which equals 72. So the main idea here, again, is when you see that picture where, you know, here's your graph, and sometimes they'll do it this way too. They'll have like a parabola maybe with a line. There'll be a section where the parabola is over top of itself. If the top minus the bottom involves the same function, it's easier to go right minus left. It's just easier. And you're looking for y equals and y equals instead of x equals and x equals in order to create your integral, evaluate the area.